Okay, so I wanted to go through the quiz I gave you for Unit 2. So first question here is the state possible zero. So this one you guys did pretty good. This is just p divided by q, where p is the last number, q is the first one. So here 4 divided by 1, but remember I need factors, so plus or minus 1, plus or minus 4, and then plus or minus 2 also works. And factors of 1 are just plus and minus 1. So when I divide all these numbers by 1, it just gives me the same list, which was answer D. Okay, and y'all did pretty good on that one. This one, I saw good things on part A, but not really in part B. Okay, and so, I'm sorry, don't remember what the graph looks like. I know it came out kind of weird on here, but I did tell you it passes through 4-0, and so remember I did change the equation so it looked like this. So first thing is to find a linear factor and also an irreducible quadratic. Okay, and so here guys, I'm just telling you do synthetic division. That's what I'm trying to tell you to do. Okay, and so a lot of y'all got stuck here. So we're gonna do some synthetic division, guys. 4, and then my values here are 1, -4, -1, and -4. Okay, and those of you who did this, you ended up doing pretty well on this. So here 1 times 4 is 4, 0, 0 times 4 is 0, -1, and -1 times -4. I'm sorry, this one was a positive 1. My mistake. So this was a positive 1. Positive 1 times 4 is positive 4. So it ends up being 0. Okay, and so this right here is the linear. So this was where my 0, so it's x minus 4. So this is the linear part. And the quadratic would be this right here, and I can't reduce it anymore, at least without getting imaginary numbers. So here, 1x squared plus 0x plus 1. So this is the quadratic. And remember, I could have simplified this a little bit more, so x minus 4 and x squared plus 1. Okay, so this was the final answer for part A. So part B is find the imaginary roots. So again, guys, I'm just going to take this part right here, and I'm going to set it equal to 0 and solve. So x squared equals -1, square root, so x is equal to positive or negative, the square root of -1. But remember, I don't have square roots of -1, so I would just call this I. Okay, this imaginary number. And so express them as linear factors. Well, the last part, so this was points, but this is what I asked for you to do to get the full points. X minus 4, and then x minus I, and then x minus -I. Okay, so this is what you needed to get the full point. This is the linear factors. Okay, so this one was an easy question, and I saw a lot of problems with it. So here, guys, I'm going through 4-0. So okay, so 4-0 is going to be one of these two right here. Okay, so I'm going to set them equal to 0. X minus 4 equals 0. X is equal to 4. This is the one that goes through 4-0. This one right here. Not this one. This one. And I'm asking for the multiplicity of just that 0. So here, guys, just looking at the individual one, multiplicity is 2. So that's what I was asking for. Okay. All right. So moving forward, number 4. Now I don't remember if this is the way I had changed this problem, guys, and if it isn't, I forgive me for it. But this is the same type of process I would go. So determine if I have any holes, guys. So here, do I see anything in the numerator and denominator that can get canceled? Yeah, I see these x plus 2. So x plus 2 is equal to 0, so I have a hole at x equals -2. Okay. Determine 0. So here I went ahead and told you x-intercepts, y-intercepts. So x-intercepts, guys, these are taken from whatever I have left in the numerator. So x-intercepts, guys, they are from the numerator. Factors in the numerator. So here, what's left in x? So x is equal to 0. So I have an x-intercept at 0, 0. I have another factor in the numerator, so x minus 2 is equal to 0. So I have one here at x equals 2. So 2, 0 is also going to be a x-intercept. Now the y-intercepts, this one is when I plug in a 0 for x. Okay, so here I'm going to plug in a 0 for x. So 0, and then I have this on top, 0 minus 2 over 0 minus 3. Okay, so I'm sorry, I had changed this part where there was no, this was the equation I left on the bottom, x squared minus x minus 6. There's no 2 here. Okay, so here I have 0 times negative 2 over negative 3, and guys, any number times 0 is 0, so this is going to be the y-intercept at 0, 0. So I'm going to go ahead and just start drawing these because I know that eventually that's what I want to do is graph this. So I'm going to have a 0 at 0, 0, and at positive 2, 0. And vertical asymptotes. Okay, so vertical asymptotes, these are straight from the denominator. So here I have x minus 3 left, so x minus 3 equals 0. So at x equals 3, I will have an asymptote. So at x equals 3, let's go ahead and just draw it in. Vertical asymptote. Okay, so now a horizontal asymptote, well, I have to look over here, guys. The highest degree I have here is 3, the highest I have here is 2. So the degree on the top is bigger than the degree on the bottom. So on this one, there's no horizontal asymptote. I have a, what we call a slant one. Okay? So in order to get this, you had to say no horizontal asymptote. So the slant asymptote I'm going to find using long division. So I'm going to go ahead and do that. Excuse me. I'm going to divide all of this by x squared minus x minus 6. So here, coefficient in front is a 1, coefficient in front is a 1. 1 divided by 1 is 1. X to the power of 1, because 3 and 2. Here I have power 3, here I have power 2. I'm just missing one more power. So now I multiply. So 1x times x squared is x cubed. 1x times negative x is negative x squared. 1x times negative 6 is negative 6x. And remember, all of these signs change. So here they cancel. 0 plus 1 is 1x squared. And negative 4 plus 6 is plus 2x. Really, this is not going to matter anyway. And now, start the process again. Here, 1 divided by 1 is 1. So this is where I can stop, x plus 1. So this right here is the y-intercept of the slant asymptote. And this is the slope over here. 1 over 1. So here at 1, and then I go 1 and 1. 1 up, 1 to the side, 1 up, 1 to the side. So this is the way my slant asymptote looks. And to finish off the graph, guys, I know I go through these points, so whoops. I have to look like this. I'm not going to touch those asymptotes. And you will have at least 2 parts to this graph. So here, guys, if I were to draw it on this part, I'm going through this x-intercept, through this y-intercept, and those are not part of my list over here. So I can't go through there. If I were to draw the graph right here, well, I would have had another x-intercept that's not part of my list. So the only really other spot where I won't touch any other intercepts is right here. Okay? So this is where that other piece of the graph should be. Okay? And I had a hole at negative 2, so negative 2, right here I have a hole. Okay, so that's the way the whole graph should look. Okay, so, the graph didn't come out on this one, but it looks something like this. Okay, so here, I would have used my answer choice again, and I saw usually a couple pretty good things here. Oops, this goes through a little bit lower. -2 here. Okay, so here, if I look at this, guys, this is first thing I would do is find zeros. So here I go through x equals -2, which means this is x plus 2, and x equals +2, so here x minus 2. So I mean, you see all the answer choices, they look like that. Okay, now this is where it got a little bit harder. So here the multiplicities, so at -2, you see how I don't cross the x-axis, I just touch it. So this means that I am in even multiplicity, so this one should have been squared. Here I went across, so this one is odd multiplicity, so this one should be odd, so this one's okay. Now what made this a little tricky is that I didn't put them in order, so that made, at least looking at this, x minus 2, x plus 2 squared, that should have at least taken away these two answer choices. And I could have just went ahead and skipped to the fourth step. So here, the y-intercept. So here, guys, I'm just going to go ahead and just go through these problems and see which one of these two will give me a y-intercept of -2. So if I plug in a 0 for this first equation, okay, -2 is equal to, here, what's 0 minus 2 is -2. 0 plus 2 is 2 squared. So here -2 times 2 squared is 4. 4 times -8 is, excuse me, times -2 is -8. That's not true. So this is not the answer. This one is. And again, let me just go ahead and plug it in. So -2, 2 squared. So here, 2 squared is 4. 4 times -2 is -8. -8 divided by 4 is -2. So is -2 equal to -2? Yes, it is. So that's why that's the answer. And the last one here, simplifying. This is just doing long division. So again, I saw some pretty good things on this one. So here, divide the 6 and the 3, so this should be 2x squared. Okay, because I had 3 on the outside, 1 on the outside. So here, 2 times 3x is 6x cubed. 2 times 3 is -6x squared. And remember, these switch signs. So here, these will cancel. -3 plus 6 is 3x squared. These come down, plus 9x minus 2. So here, start again. 3 divided by 3 is plus 1. These are all pluses, right? So these didn't come out very good. But so plus 1x, and from here, go ahead and start again. So 1x times 3x is 3x squared. 1x times -3 is -3x, but I switch the signs. Excuse me. So here, 9 plus 3 is 12x. Bring down the 2. So 12x, again, divided by 3 is 4. And I'm going to start again. Plus 4 times 3x is 12x. And 4 times 3 is -12. But these switch. Oops. So this canceled and this becomes a 10. So the remainder here was plus 10 over 3x minus 3, which was answer A. Okay, so just a quick review on what we did on the quiz, and so you guys are getting these back today. So go ahead and just go through them, and you'll see something similar so on the exam. So go ahead and just go through them.